Hello and welcome to PA Academy. So in the previous part of this video, we've looked at grad, that's gradient of a scalar vector. So we've looked at it extensively, and in this part of this video, we are going to be looking at divergence of a vector function. All right. So if you missed the previous set of video under grad, just check the playlist on engineering analysis. You're going to find some of those videos there. But right now, I want to deal with divergence. All right. So in dealing with divergence, if you have a function, a vector function with, let's say, vector function, so let's just say vector function A, and is having coordinates x, y, and z, and we have to look for the divergence. Now, for divergence of a vector, we also call it div. That's div. Exactly. So, and now this is the function you are given, and you are asked to look for the divergence of A. So that will be div of A. So it's also represented as this. So this is more like the grad function and the dot product of A. So let me just put it that way. So if you have to write this mathematically, that will just be the partial differential with respect to x I plus, okay, so this will be j of dy plus partial differential with respect to z, sorry, then k multiplied by the dot product, exactly, of A. So that's axi plus ayj plus azk. So that is the formula to calculate the divergence. So what we are having here is the formula you are going to use to calculate the divergence of a vector function. So don't worry, when we look at examples also, you're going to understand the application. And in another video, I'm still going to be explaining the difference between the gradient of a scalar vector and then the divergence of a scalar vector, so that once you understand the difference, you know what to do when you come across a question, and when you have your answer, you'll be sure that, okay, yes, I've carried out divergence and not gradient, or I've carried out gradient and not divergence, so that you don't mix the two of them up. Exactly. All right, so this is the formula you have to use to calculate the divergence of a vector function. Exactly. So one thing I didn't write is the function itself. Exactly. So let me just rub this off. So let's say the function itself, which is A. We've taken the function as A. Remember, when we are dealing with grad, we're working more with file. So it could be any alphabet, it could be any symbol. It's just that, just understand the concept. So let's say the function itself is given as if A is ax of I plus ay of j plus az of k. Exactly. All right. So what I want to do now is, let's look at one example to use it to explain what we have on the screen. So the question says, if A, which happens to be the function is given as this: s square yi plus xyzj plus yz square k. So this is the function. We are asked to look for div A, or div A. That's the divergence of the function A. So now let's do this, and remember, we already have the formula to calculate it, which is what we are having above. So that means we are going to be having del cross dot product of A will equals to, so that means we are going to be having the partial differentiation with respect to x of I plus. So you need to actually write out this formula again, then of k multiplied by the dot product of the function. Now the function we are given is x square y, and the coordinate is I plus xyz j plus yz square k. Okay, so now remember when we are dealing with dot products. So for dot products, I think we did a little of it in the previous part. So for dot products, the I will multiply. So what we are having here will come and multiply this, and then this will multiply this, and this will multiply this. So in doing that, you are going to be having something that looks like this. So that means you are having the partial differentiation with respect to x of, so I said this here is multiplying this of x squared y, and remember I said once they are multiplying themselves, the coordinates will no longer be there. So plus partial differentiation with respect over partial differentiation of y. So this is multiplying this. That will be x, y, z. Again, the j will no longer be there, plus. So this will come and multiply this of yz square. Alright. So now if you should differentiate what we are having here, so let me just change the color. So if you differentiate what, and if you look for the partial differentiation of what we have in here, that means we differentiate with respect to, look for the partial differentiation with respect to x. So we are going to be having 2xy plus, if you look for the partial differentiation of this with respect to partial differentiation of y, so that's going to give us xz plus, so if you do that of this, this should be z. So you just have to be careful with some of these mistakes. Exactly. So if you should differentiate this, it's going to give us 2, because we are really differentiating z square, and z square is 2z. Then this y is taken as a constant, so that will be 2yz. So with this now, we already have our answer. So you can just conclude that the div of a, so this is how you write it, the div of a is equals to 2xy plus xz plus 2yz, and that is it. Exactly. So this is the first example we are going to be looking at under divergence of a vector function. We still have more other examples and other topics we are still going to look at under divergence, call, and gradients. Exactly. So if you find value in this, please give it a thumbs up, and if you have any doubts or any question, do not hesitate to leave them in the comment section. And if you are yet to subscribe, please click on that subscribe button to subscribe. So in the next video, we are going to be looking at another example under divergence. So I'll see you all in the next one.